Hello, my name is Sung Son. Welcome to our online digital dentistry seminar hosted by Pusan National University Dental School. I'm very pleased to have the opportunity to talk to you today. We are doing a pre-recorded online conference. Please feel free to type any question and comments in the chat. I will try to answer them as we go along. These are the members of our department who have accomplished many things in our dental school according to our individual dental specialties. Let's move on to today's topic. This is a case of one-day chairside CAD-CAM restoration. The dentist performed tooth preparation of the second upper right premolar for inlay restoration. Then they acquired the intraoral scan image using an intraoral scanner. Then they designed the cavity foam using CAD software. And after finishing the CAD procedure, they push the button for the milling process. The entire process only 2 hours from tooth preparation to final cementation of the inlay restoration. Presently, the use of CAD-CAM restoration has increased due to its ease of use and speed of recovery. Indirect restorations can be manufactured in various methods. Conventional pathway for fabricating restorations has many steps, including procedural errors. However, digital workflow provides accuracy of restorations as well as convenience. We can make CAD-CAM inlays using a variety of materials. As shown on the screen, the inlay can be made of root-side glass ceramic material, and it can also be made of lithium disilicate, which has superior strength to root-side. In addition, restorations can be fabricated with a hybrid block of resin matrix and ceramic components. Among CAD-CAM restoration materials, silicate ceramic include feldspathic glass, root-side ceramic, and lithium disilicate ceramic block. Their greatest features are that they are aesthetically superior, and hydrofluoric acid is applied, this surface becomes rough and irregular. This leads to greater adhesion when resin cement is applied. This is the recommendation for hydrofluoric acid etching time of a silicate ceramic block. Usually for enhanced ceramic, such as lithium disilicate, 10% hydrofluoric acid requires 20 seconds of etching time, and 5 hydrofluoric acid requires 30 seconds of etching time. Then, a silane application is one of the ways to improve the bond strength of the silicate CAD-CAM block. We can confirm the nature of the surface of silicate ceramic materials which a silane primer was applied to. This process makes the material ovic surfaces can create more favorable outcomes when bonding to the resin cement. An experiment was reported to measure the bonding strength of a group treated with hydrofluoric acid silane coating, or hydrofluoric acid and silane together on each surfaces after wearing the mechanical surface treatment of an Emax lithium disilicate block. A significantly higher bonding strength was observed in the groups where hydrofluoric acid and then silane primer was applied compared to the hydrofluoric acid treatment only groups and the silane application only groups. Therefore, the most important thing is that the glass ceramic block needs to be treated with hydrofluoric acid in order to form the interlocking of the resin to form porosity on the surface and increase the surface area of the glass ceramic. Secondly, applying silan enhances the chemical interaction between resin cement and the ceramic surface. Moreover, in the dental market, 3 types of silan products have been released. First, a pure silan, a porcelain primer containing only silan monomer components, products that can be used as a porcelain primer as well as a zirconia primer, including both a silan and acetic phosphate monomers. And third, products containing silan components in adhesives with functional monomer, such as MDP, have been introduced. Among them, it has been reported that pure silan products showed superior ability to produce siloxane complex well because of their chemical stability. In this review article, glass ceramic treated solely with silan solution showed a better bonding with resin cement than ceramics treated with a primer containing both silan and MDP. They showed that a pure silan primer AS group has a stable, higher bonding strength compared to both the group of silan primers found in universal adhesives and the group of silan primers used with zirconia primer. To summarize, for optimal adhesion between silicate CAD-CAM block and a tooth, a key points of surface treatment of silicate CAD-CAM block are a proper hydrofluoric acid etching and silan application. Silan can create a favorable environment for resin cement. Moreover, in the dental market, various silan products have been released. It has been reported that pure silan products showed superior ability to produce a siloxane complex well because of their chemical stability. Zirconia is a popular material in CAD-CAM restoration. However, zirconia doesn't contain silica. Therefore, when hydrofluoric acid is applied, it does not react chemically like a silicate ceramic block. And silan application is also ineffective on the zirconia bonding. Even though zirconia doesn't contain silica, zirconia can react chemically with MDP. When zirconia primer containing MDP was applied to polished zirconia, it showed higher shear bond strength compared to other groups. MDP is a representative functional monomer within the phosphate hydrophilic group. It can react the zirconia surface. The phosphate hydrophilic group of MDP forms a chemical bond through an additional reaction with the zirconia surface. Therefore, when MDP primer or a self-adhesive resin cement containing MDP is applied, the bond strength of the zirconia block can be improved. There are a variety of zirconia primers on the market, especially universal dental adhesives also can be used for zirconia primer. However, when universal dental adhesives are applied to the inner part of zirconia restoration as a zirconia primer, you have to be aware that light curing must be performed for the chemical stability of the universal adhesive, and you have to be aware that film thickness may increase because the universal adhesive is thicker than other primers. Mechanical surface treatment of zirconia is important. A sandblasting process is effective to clean the zirconia surface and to increase the surface roughness. The general recommendation for sandblasting of zirconia is to blast 50 micron sized alumina oxide particles at 2 bar for 5 seconds onto the zirconia. In this study, sandblasting was performed at various distances and at various air pressure to measure the fracture strength and to observe the microsurface image of zirconia. In this study, they found is that when over air pressure was applied on the zirconia during the sandblasting, microcracks can occur. Therefore, it is recommended that you follow the previous mentioned general guidelines during the sandblasting of the zirconia. To summarize, the key points of surface treatment of zirconia CAD-CAM block are proper surface sandblasting and zirconia primer application. MDP can create chemical bonding between zirconia and MDP. It can improve the bonding between zirconia and resin cement. Therefore, if teeth are shorter than 2 mm and tapered, use the MDP primer and resin cement for zirconia bonding. Let's move on to the bonding of the hybrid ceramic block. Hybrid blocks are broadly divided into two groups. Number one, a nanoceramic block, in which ceramic particles are mixed in a cross-linked resin matrix. Number two, polymer infiltrated ceramic network blocks, in which polymer is injected into the ceramic network structure. Since the hybrid block contains polymer, it has flexibility similar to dentin, so it is less brittle than dense ceramic material. And importantly, it is reported that its machinability is better than ceramic material in the milling process. And importantly, it is reported that its machinability is better than the ceramic material in the milling process. Several products are being introduced. This is Magic Duo Hydroblock Hybrid. This is Magic Duo Hybrid block made by Korea. After the milling process, many hybrid ceramic doesn't need any post-treatment. It has the advantage to be finished by grinding immediately without any post-treatment. The gloss and surface property of the restoration can be improved depending on the degree of polishing. The more polishing used, the more glossy it becomes. When a sandblasting is applied to the hybrid block, fine surface roughness can form. In addition, there is a ceramic component included in the hybrid block, so when hydrofluoric acid is treated, the roughness of the surface can increase. And the CeraSmart, a name of a brand of hybrid block, are made by injecting a ceramic particle into the resin matrix. Pore-like holes were observed after hydrofluoric acid treatment. On the other hand, Dynamic, another brand of hybrid block made by injecting a polymer into ceramic network, shows a same image similar to that of a ceramic treated with hydrofluoric acid. This is a picture obtained our department of the porosity obtained after applying hydrofluoric acid on the enamel surface. However, when phosphate acid was treated on the hybrid block, it was similar to untreated surface, and the effect of roughening could not be observed. However, it was possible to check the cleansing effect on the surface. Meanwhile, there is a report of surface treatment, such as silent treatment on hybrid blocks. The groups that skip the silent treatment after sandblasting, the surface of CeraSmart and Dynamic blocks showed lower bond strength than the group treated with silent, especially after 6 months of aging. Silent application had a greater effect on the result. Therefore, the following conclusion can be drawn about the bonding of the hybrid CAD-CAM block. First, mechanical roughening is necessary. Sandblasting can create rough surface of CAD-CAM block. Second, Hydrofluoric acid can dissolve the etchable nanoparticle of hybrid CAD-CAM blocks. Third, siliconization is crucial to maintain an optimal adhesion, and surface roughening of the phosphoric acid etched surface is similar to that of the untreated surface. It is a hybrid block restoration protocol recommended by the Magic Duo company. They recommended sandblasting or hydrofluoric acid treatment for surface roughening and silane application for chemical bonding of a hybrid block. CAD-CAM restoration is manufactured through the milling process by machine. Therefore, when milling, the thickness and the length of the milling bar must be concerned. If there is a discrepancy between the thickness of milling bar and abutment, over-milling problems can occur. Over-milling caused by the mismatch of size between the milling bar and the tooth will result in increased cement space. Cavity formation with undercut can also cause increased cement space problems. As you can see, the increased cement margin eventually causes discoloration and secondary caries. Resin cement shrinks during polymerization, and the increased cement space adversely affects the long-term prognosis of the restoration. CAD-CAM restoration has a wider range of marginal gap compared to conventional restorations. Ranges from as little as 3.7 microns to as much as 206.3 micron have been reported. Therefore, to reduce the problem of increased cement space, many clinical trials have led to dental products and techniques. Therefore, to reduce the problems of increased cement space, many clinical trials have led to dental products and techniques that have been introduced to dentistry. One of them is the delayed photo activation technique. This article said that a delayed light activation of dual cure cement decreased the post-gel shrinkage. Moreover, delayed photo activation did not negatively affect the mechanical properties of the resin cement. It has been suggested that a photo activation immediately after resin cement mixing may negatively affect the self-curing mechanism because a rapid formation of a cross-link polymer, the light exposure, leads to entrapment of the activators and initiators needed for a self-cure reaction. This article said that delayed light activation of dual cure resin cement decreased the post-gel shrinkage. Moreover, delayed photo activation did not negatively affect the mechanical properties of the resin cement. It has been suggested that the photo activation immediately after resin cement mixing may negatively affect the self-curing mechanism because a rapid formation of a cross-linked polymer on the light exposure leads to entrapment of the activator and initiators needed for the self-cure reaction. Therefore, when dual cure resin cements are applied, wait for 3 to 5 minutes before performing photo light activation. Then, remove the excess of the resin cement. Provide enough time for self-cured polymerization. Finally, photo light activation can be done. In summary, today we talked about the bonding for silicate ceramic, zirconia block, and hybrid blocks. Moreover, we must remember the increased space between the cement and the tooth due to the milling procedures of CAD-CAM restorations. We must also remember the importance of delaying a photo activation to reduce the shrinkage of polymerization in resin cement. For the successful bonding of CAD-CAM restorations, we must have an understanding of the characteristic of CAD-CAM materials. Then, we also must understand about the surface treatment of material to improve the surface cleanliness and roughness. The adhesion between tooth and resin cement is also important. For achieving proper adhesion between the tooth and restoration, we must go back to the basic principles of adhesion and perform new clinical trials. And thank you for your attention. I hope that you learned something new from this presentation. Thank you.